from this course. In the first section, we'll develop a conceptual understanding of continuous integration, continuous delivery, and continuous deployment, and the difference between those concepts. Then, we'll talk about different phases of adopting continuous integration into your organization. We'll give a brief introduction to Jenkins and the history of Jenkins. Next, we'll learn how to install Jenkins on your local computer. No matter whether you are using Windows, Mac, or Linux, you will be able to follow along. Then, we'll get to know Jenkins master and slave architecture, develop our understanding of some of the most important Jenkins terminologies, such as jobs, builds, and nodes. And we'll try out our first Jenkins job, which simply prints out "Hello World" in the console. In Section 2, we're going to create and run a Maven project, since Jenkins natively understands Maven and offers excellent features for Maven-based projects. This project involves checking out source code from GitHub, compiling, running unit tests, and packaging the application. In the end of Section 2, we'll cover other Jenkins build triggers, such as trigger build remotely, build after other projects are built, and build periodically. In Section 3, we'll be focused on continuous inspection. We're going to learn how to produce code quality and code coverage report, such as check style report for our Maven project. We would also talk about Jenkins support for other build systems, such as Apache Ant and Gradle. In Section 4, we're going to extend our existing Jenkins job to an automated continuous delivery pipeline, which will deploy our application to a staging and production environment. In this section, we'll create multi-stage Jenkins jobs and visualize the complicated build pipeline with Jenkins Build Pipeline plugin. We would also cover how to shorten the build time by running projects in parallel. In Section 5, we'll see how to scale our Jenkins workflow with Jenkins master and slave architecture to deploy and configure a multi-node Jenkins cluster in the cloud environment. In the end, we would also look at some advanced tricks, such as labeling Jenkins nodes, so that we can reserve some specific Jenkins nodes for certain kinds of jobs. That's it for this introduction lecture. I'll see you later. Hello everyone, in this lecture we're going to talk about how you should take this course and how to get support. A lot of slides provide practical information on how to do things. The source code for this course is uploaded to GitHub. We'll also keep the repository up to date with new and extra information. We have put most of the complicated commands we're using this course to the text lecture right after the video lecture so that you can copy and paste those commands and try out on your own laptop. We also have a Facebook group called Learning DevOps and Level Up. Facebook group is a fantastic tool that we can use in so many of the communities we're in, and we hope it would be a great way for extending this course and adding more value to your learning. You can post your questions in the Facebook group and we'll try to get back to you as fast as we can. We'll also periodically share the latest trend in the DevOps world and some practical tricks we found useful. You can scan the following barcode or use the link in the next text lecture after this video lecture to find the group. In this lecture, we're going to talk about what is continuous integration, why we need it, and different phases of adopting continuous integration. Jenkins is a continuous integration and build tool. We need to understand continuous integration before we start playing with Jenkins. Continuous integration is a development practice that requires developers to integrate code into a shared repository several times a day. Each check-in is then verified by an automated build, allowing teams to detect problems early. A continuous integration system usually involves a tool that keeps monitoring your version control system. Whenever a change to version control system is detected, the system would automatically build and test your application. If the build or test is not green, the system immediately notifies the developers to fix the issue right away. So why do we need continuous integration? One of the motivating forces behind CI is to detect problems or bugs as early as possible In the development lifecycle, since the entire code base is integrated, built, and tested constantly, the potential bugs and errors are caught earlier in the lifecycle, which results in better quality software. Next, let's talk about different stages of adopting continuous integration. Introducing continuous integration into your organization is not something can be achieved in just one step. Usually, it takes you on a path that progresses through several distinct stages. Let's take a look at an approximate picture of each stage. Stage 1. There are no build servers at all for the team. The application is built manually on a developer's machine. The source code is stored in a central repository, but is not enforced that developers need to commit their changes on a regular basis. What happens is that before release, a developer or a release manager would manually integrate the changes. During this stage, the code changes made by all developers were brought together and forged into a product. This sometimes involves integrating months of conflicting changes, which makes it very hard to anticipate the types of issues that would come up. Also, it takes a lot of effort to resolve those issues because lots of the code might be written months ago. Thus, this painful process can cause significant release delays. Stage 2. The team has a build server, and automated builds are scheduled on a regular basis, typically nightly basis. This build script would compile the application and runs a set of automated tests. Developers now commit their changes regularly, usually at the end of every day. If a developer commits conflict with another developer's work, the build server would alert the team members. Stage 3. The team is now starting to take continuous integration and automated testing to a further step. The build server is configured to start a build whenever new code is committed to the central repository. The build process usually involves compiling the application and runs a set of automated unit or integration tests. The build server alerts team members immediately if a build fails. Broken builds are usually treated as a high priority issue and is fixed quickly. Stage 4. Automated code quality and code coverage metrics are now run along with unit tests to continuously evaluate the code quality. Gradually, the CI process gathers useful information about our code base. We'll be able to answer questions such as, is the code coverage increasing? Do we have fewer and fewer build failures? This helps teams keep the quality bar of the code base high. We'll be notified if good testing practices are slipping. Stage 5. Confidence has been built up in the automated unit, integration, and acceptance tests, so that automated deployment techniques can be used to push out new changes directly into production. Next, let's talk about the difference between continuous integration, continuous delivery, and continuous deployment. There is a lot of confusion about these buzzwords. Continuous integration is the practice of merging development work with the main branch constantly so that the code is tested as often as possible to catch issues early. Continuous delivery is the continual delivery of code to an environment once the code is ready to ship. This could be staging or production. But the idea is the product is delivered to a user base for review and inspection, which can be QAs or customers. Unit tests during continuous integration cannot catch all the bugs in business logic, particularly design issues. This is why we need a QA or staging environment for testing. Continuous deployment is the deployment or release of code to production as soon as it's ready. Continuous deployment requires continuous integration and continuous delivery. Otherwise, the code quality won't be guaranteed in the release. So how can we implement continuous integration? There are different products and tools which can help you implement continuous integration in your organization. Some tools let you host the CI servers in your own network infrastructure, such as Jenkins. There are some other hosted CI products, such as Circle CI, which is completely hosted in the cloud. In this course, we'll be focusing on Jenkins server. Continuous integration is also a mindset. When continuous integration is introduced into an organization, it dramatically changes the way how organizations think about the whole development process. Continuous integration is not only a toolset, but also a mindset. In order to get the most out of continuous integration, a team needs to adopt a CI mentality. Fixing broken builds should be treated as a high priority issue for all team members. The deployment process should be automated with no manual steps involved. All team members should focus on contributing to high-quality tests. Each of these requires improvements in the practices and engineering culture of continuous integration across the organization. In this lecture, we'll give a brief introduction about Jenkins and the history of Jenkins. Jenkins is a continuous integration and build server. It's used to manually, periodically, or automatically build software development projects. These projects builds can include complication, running automated tests, packaging application, or even deploy to production. Jenkins is an open-source continuous integration tool written in Java. Jenkins is used by teams of different sizes for projects with various languages such as Java, .NET, PHP, Ruby, Groovy, etc. So why Jenkins have been so widely used? Firstly, it's very easy to use. The UI is simple, intuitive, and visually appealing. And Jenkins as a whole has a relatively low learning curve. As we'll see in the next few lectures, you can get started with Jenkins in just a few minutes. Also, it has great extensibility. It's extremely flexible and easy to adapt to your own purposes. You can find thousands of open source plugins are available. These plugins provide various functionalities, such as version control systems, code quality metrics, build notifiers, UI customization, etc. Next, let's talk about the history of Jenkins. Jenkins was originally developed as the Hudson project. Hudson's creation started in the summer of 2004 at Sun Microsystems. One of Sun's developer called Kusuke Kawaguchi started the project as a hobby project under the name of Hudson in late 2004. It was first released in February 2005. As Hudson evolved over the years, it was adopted by more and more teams within Sun for their own projects. By early 2008, Sun recognized the value of Hudson and asked Kusuke to work on Hudson full-time and to provide professional services and support around Hudson. By 2010, Hudson had become the leading continuous integration solution with a market share of over 70%. In January of 2011, the project name was changed from Hudson to Jenkins. That's it for this lecture. I hope you've enjoyed it. In this lecture, we'll learn how to install Java on our local laptop. Jenkins is a Java application and requires at least Java 7 to be installed on your local machine in order to run Jenkins. And it's recommended to install Java 8. First, let's verify if Java is installed on your laptop. Here, just launch a command line terminal, then type java-version. If you already have Java installed, this command would print out which version of Java is currently being used. If you don't have Java installed on your laptop or your Java version is older than 7, let's move on to install Java on your laptop. If you already have the desired Java version installed, you can skip to the second half of this lecture to configure Java home environment on your laptop. Here, we Google install Java SE. The third entry is the official website to download Oracle Java Development Kit. Just click the link. On the Java SE Development Kit downloads page, accept license. Click the corresponding installer that matches your platform. Since I'm using Mac, I'll download the Mac installer. I'm fast-forwarding the video until the download is complete. Once the installer has downloaded, just run the installer and accept all defaults. Type your password to proceed. Now the download is complete. Next, we'll configure the Java Home environment variable. Java home environment variable points to the installation path for the Java development kit, and is required by other applications which uses Java. The steps to configure Java home environment variable vary depending on what operating system you are using. I'll be demoing how to configure Java home environment variable on Mac. If you're running Windows or a Linux machine, you need to follow the instruction on the next lecture. First, let's find out where Java is installed. On Mac, Java is usually installed under /library/java/Java virtual machines. Let's enter the directory. Then let's list what's under the directory. As you see, I have several different versions of Java installed on my laptop. Let's enter the one we just installed, which is JDK 1.8.0 101. Then enter Contents, Home. Now the current directory is the directory where Java is installed. Just do pwd and copy the path of current directory. Then open the .bash_profile file, which is usually under the home directory. This file is read and the commands in it are executed by bash every time you log into the system. The best part is that this file is specific to a user, so it won't affect other users on the same system by changing it. Here, let's export the environment variable Java home to the path which we have just copied. Then just save the file. Now we're done with configuring Java home. Next time, when you're logging in the system, the Java home environment variable will be automatically set to our current Java installation path. That's it for this lecture. I hope you've enjoyed it. In this lecture, we'll install Jenkins on our local box. Just Google install Jenkins. Let's scroll down and click the Jenkins installation and setup page. Then click the Downloads on the top left. Let's download the LTS release, which is a long-term support release. The current LT release is 2.7.2. Just mouse hover the red button with LTS release version. It displays a drop-down menu with all different operating systems that Jenkins supports. Since I'm using Mac, I just click Mac OS X. If you're using other operating systems, just click the one that matches your operating system. Now it's downloading the Jenkins installer for Mac. I'm fast forwarding the video until the download is complete. After the installer is downloaded, let's open it up. Just click Continue to proceed. Then agree to the license agreement. Then type your password to continue. After the installation is complete, the installer launches the browser and opens up localhost port 8080, which is the default port that Jenkins runs on. For the sake of security, Jenkins has written the initial login password for admin user to the following file. Let's copy the file path and display the file content in a terminal. Oops, we don't have permissions to access this file. Just add sudo to run the command with security privileges. See? We have retrieved the admin password. Just copy the password, go back to the login session and paste it to the input box, and click Continue. Now Jenkins is suggesting us to install some Jenkins plugins. We'll talk more about plugins later. For now, we just click the cross sign on the top right to skip the step. Finally, Jenkins is ready. Click Start using Jenkins. Now we're logged in Jenkins. First thing we do here is to change the admin password to something more meaningful so that we don't have to copy and paste the lengthy random string each time we log into Jenkins. Just click this admin user account on the top right. Then Configure. In the password section, just type the new password. Click Save. We're done with resetting the password. So next time you can use admin user ID and the password you just set to log into Jenkins. That's it for this lecture. I hope you've enjoyed it. In this lecture, We're going to take a look at Jenkins master-slave architecture and introduce some important Jenkins terminologies. Jenkins uses a master and slave architecture to manage the distributed builds. The master's job is to handle scheduling build jobs, dispatching builds to the slaves for the actual job execution, monitoring the slaves, and recording the build results and presenting the build reports. It's worth mentioning that even in a distributed architecture, a master instance of Jenkins can also execute build jobs directly. A Jenkins slave is a small Java program that listens for requests from the Jenkins master. The job of the slaves is to do as they are told, which is mainly executing build jobs dispatched by the master. It is possible to configure a job to always run on a particular slave machine or a particular type of slave machine. Next, we'll get familiar with some of the key concepts within Jenkins. The first one is job or project. Jenkins seems to use these terms interchangeably. They all refer to runnable tasks that are controlled or monitored by Jenkins. Slave or node. Slaves are computers that are set up to build projects for a master. Jenkins runs a separate program called slave agent on slaves. When slaves are registered to a master starts distributing loads to slaves. Node is used to refer to all machines that are part of Jenkins grid, slaves, and master. Next is executor. Executor is a separate stream of builds to be run on a node in parallel. A node can have one or more executors. A build is a result of one of the projects. A plugin, like plugins on any other system, it is a piece of software that extends the core functionality of the core Jenkins server. That's it for this lecture. I hope you've enjoyed it. Hello. In this lecture, we'll give a high-level overview of Jenkins Web Console. Let's go to Jenkins Web Interface first. Just go to localhost port 8080. Then type admin and the password is set in the last lecture to log into a Jenkins Web Interface. The main section on the landing page is a job listing section, which is supposed to have our job list. However, since this is a fresh installation of Jenkins, therefore no jobs are listed yet. On the left-hand side, there are some menu items, build queue, and build executor status. Let's take a look at these menu items. A new item. The item refers to a job or a project. So this menu item helps us to create a new job. Next is people. This menu item manages users within Jenkins. Build history shows us a history of builds in this Jenkins instance. It includes the builds that were executed not only on the master node but also on the slave nodes. Next is Manage Jenkins. Let's take a quick look into this section and explore some of the items on this management page. This Configure System item can help us to configure global settings and paths, such as the path to Maven and Java. The Configure Global Security item configures who can view and edit the Jenkins system through this web console. The Manage Plugins item can add, remove, disable, or enable plugins that can extend the functionality of Jenkins. We will explore Jenkins plugins in greater detail in a separate lecture. Next is System Information and System Logs. These are useful if we want to troubleshoot some of the Jenkins system issues. So that was a high-level overview of Manage Jenkins page. Let's get back to the landing page again. My Views item would display a private view which provides a possibility for every user to have its own filter of Jenkins jobs. The last menu item here is the Credentials menu item, which is responsible for managing all the global credentials in Jenkins. The Build Queue status here shows all the builds that have been triggered. Next, on the Build Executor section displays the current build executors on this Jenkins instance. That's it for this lecture. I'll see you later. Hello and welcome back. In this lecture, we'll start creating our first Jenkins job. We're now at the landing page. There aren't any jobs created. You have a nice little inviting message to create a new job. So let's click on Create New Jobs. Then we need to give the new job a name. Basically, the project name can be anything you like. But it's worth noting that it will be used for the project directory and the build job URL. So we should avoid names with spaces. Here we name it first-Jenkins-job. Next is to choose the type of project we want to create. Currently, we have only freestyle project. Jenkins is really versatile. Can be used to perform lots of different build jobs, such as continuous integration, nightly builds, perform some repetitive batch tasks, etc. Freestyle build jobs are general-purpose build jobs, which provides a maximum of flexibility so that you can tailor it to your needs. Next, we're going to start off with the freestyle project. So select that item and then click on the OK button. Next, let's input the project description. The project description will go on the project homepage. It provides an overview of the build job's goals and context. Just type, "This is our first Jenkins job." Now we're at the job configuration page. As you see, the job configuration page has been divided into several sections. The first section is some basic information, such as the name and description of the project, which we have already filled in, and some other options about how and where the build jobs should be executed. The other options are more technical. You can disable old builds. Build jobs can consume a lot of disk space, especially if you store the build artifacts. Even without artifacts, keeping a record of every build job consumes additional disk space and memory. The Discard Old Builds option lets you limit the number of builds you record in the build history. You can either tell Jenkins to only keep recent builds or to keep no more than a specified number of builds. You also have the option to disable the build. A disabled build will not be executed until you enable it again. Using this option when you create a new build job is quite rare. But this option is very handy if you want to temporarily suspend a build during maintenance work or major refactoring. The next section is the source control management section, which defines the source of the code which will be built by our job. Jenkins supports CVS and SVN out of box. Our first Jenkins job won't check out any source code, so just leave none as default. The next section is the build trigger section. We can define multiple triggers for this job. If we don't specify any triggers, the job can only be triggered manually. In our first job, we'll trigger this job manually. And next is the build section, where we define the actual build steps. Build steps are the basic building blocks for the Jenkins freestyle build process. Build steps tell Jenkins exactly how we want our build project. We can define as many steps as we want within a job. Here we click Add Build Step. Then we select Execute Shell. If you're on a Windows system, you probably want to select Execute Windows Bash command. Then we just echo Hello Jenkins, which should print out Hello Jenkins message for us. The last section is the post-build section, where we can define some most build processing steps. These steps will execute where the build is successful or not. Usually, we use the post-build jobs to define our notifications to send out emails to the development team. Jenkins can also collect information out of the build, such as archiving the artifacts, recording Java doc, and test results. We won't do any post-build actions in this demo, so let's leave it empty. Now we're done with configuring our first job. We can click on the Save button. Great! After saving the configuration for our first job, let's go back to our landing page. See? The new job appears on our landing page. That's it for this lecture. I'll see you later. Hello, and welcome back. In this lecture, we're going to build our first Jenkins job, which we created in the previous lecture, and inspect the results. Now, we're at the landing page of Jenkins. On the right side of the landing page, under an All tab, Jenkins lists all jobs that we have created in our Jenkins interface. We have only created one job so far. Let's just click the Build Now button on the last column of our project entry to fire off our first job execution. Then we click the job name to enter the main page of the project. See? That build was scheduled. There is a blue ball displayed under our build history. This tells us the last known state of our build. In Jenkins, blue ball indicates success. And if we click on the ball, it takes us to the main page for this build. Now, if we click Console Output, we can see the console output of that job. See? It prints out Hello Jenkins in the console. You also have the option to delete the build, which we may do later. Let's go back to the landing page. Click back to Project, then back to Dashboard. On the job list, it shows First Jenkins job, which is our first job. And then which build number that I'm on. Currently, it's build number 1. If you click on build number 1, Jenkins will take us to the main page for this build, which we just saw. The first column is Status column. As we mentioned before, the blue ball indicates the last run was successful. The second column is the weather, which shows an aggregated trend of all the builds that had happened recently. Sunshine means that all the recent builds are successful. Then we have the last failure. Since we haven't had any failures, N/A is displayed. Next to the last failure column, we have the last duration column, which displays how long the last build took. In our case, it is 93 milliseconds. And then in the final column, we have a Build Now button, which will allow us to trigger an immediate build. That's it for this lecture. I hope you've enjoyed it. In the previous lecture, we have seen how to create and trigger a simple Jenkins build job. But the Jenkins job doesn't do much besides printing out the Hello Jenkins message. In this and the following few lectures, we'll set up a more practical Maven-based build. This Jenkins job would check out the source from GitHub, compile the code, run the test, and package the application. The project we're going to build is a very simple Maven project. Since it's a Git project and it's hosted on GitHub, we'll need to install Git on our local box and install GitHub plugin on Jenkins. Let's start by installing Git. If you already have Git installed, you can skip this step. To verify if Git is installed on your local box, just open up a command line terminal and type git ---- version. If Git is installed, you would see the Git version printed out on the screen. Now, let's Google download Git. The first entry is the official Git installation page. The installation steps vary depending which operating system you're running on. Since I'm using Mac OS, I just click Mac OS 10 to download the Git installer for Mac OS. You should select the one matches your operating system. Now, the Git installer has been downloaded. I'm fast-forwarding the video until the download is complete. Now the installer is downloaded. Let's open up the installer. Just click Continue to go with the default option. Type your credentials to proceed. Now the installation is complete. You can verify Git is successfully installed by running git ---- version. Next, let's move on to install GitHub plugin for Jenkins. This plugin integrates Jenkins with GitHub projects. You can learn more about this GitHub plugin by visiting the plugin page. Here I am at the Jenkins landing page. Just click Manage Jenkins, then go to Manage Plugins. Click on the Available tab. The plugins that we're interested in is the GitHub plugins. Let's go to the filter search and type in GitHub. See? Jenkins located the GitHub plugin for us. Then click the checkbox next to it. There are two buttons to install the plugin: Install without restart, and Download now and install after restart. Since Jenkins 1.442, we're able to install new plugins without restarting Jenkins. When installing new Jenkins, we usually choose Install without restart. If you are upgrading a plugin, we need to choose Download now and install after restart. Here we click on Install without restart. Now Jenkins starts the installation process. If this is fresh install for you, you might have noticed that Jenkins is also installing some other plugins for us. This is because Jenkins automatically found any dependency plugins, such as the GitHub API plugin and the Git plugin, and included those as well. When the download is complete, we should see the success bar here. Now we go back to the landing page. Let's click Manage Jenkins again. Then click on Manage Plugins. This time we click the Installed tab. See? We have our GitHub plugin installed, and the version is 1.21.1. That's it for this lecture. I hope you enjoyed it. In this lecture, we'll continue our preparation work to set up our first Maven-based build job. We'll be installing Maven in this lecture. The project we're going to build is managed by Maven Build Framework. Maven addresses two aspects of building software. First, it describes how the software is built. And secondly, it describes its dependencies. There are many Java build tools available, such as Maven, Ant, and Gradle. Gradle is getting more and more popularity, but Maven is still the most widely used one at this moment. Jenkins provides excellent support for Maven and has a good understanding of Maven project structure dependencies. Let's Google download Maven. The first entry is the official Apache Maven website. Now we're at the download page. Scroll down to the available download options. Let's pick the binary zip. Go to the column for the link and click on the link. Now it's downloading the entire distribution for Apache Maven. I'm fast forwarding the video until the download is complete. Once the .zip file has completed downloading, it should appear in the download folder. I prefer to place all my development tools in a common place, which is the document folder, but this can be any location on your local box. Next, let's extract the .zip file. In Mac OS, I just double-click the .zip file. In Windows, you can right-click on it and then choose Extract All from the pop-up menu. Once the extraction is complete, a new folder would appear under the same directory. The folder should be named after Apache Maven plus the version number. Next, we need to add the bin directory of this new folder to the path environment variable so that our operating system knows where to find our Maven executable. This step varies depending which operating system you're running on. If you're using Mac or Linux, you should be able to follow along. If you're using Windows, just go back to the Maven download page and click Install, then scroll down. Just follow the Windows tips section to update the path environment variable. Now, let's see how we can do this on a Mac or Linux machine. First, let's get the full path of the Maven executable path. Just enter document directory, then the extracted folder, then bin directory. Let's do pwd to print out the current directory. Then copy and paste the full path. Let's open up the .bash_profile bash file. Let's add one more command to add the Maven executable path to the path environment variable. Then exit the file. Now we'll source the bash file to load the environment variables in the current session. Once everything is set up correctly, if we type mvn-v here, it would print out the Maven version for us. That's it for this lecture. I hope you've enjoyed it. Hello and welcome back. In this lecture, we're going to set up our Jenkins configuration in order to run our first Maven-based project. To set up Jenkins configuration, go to Manage Jenkins. Then click Global Tool Configuration that loads the Jenkins configuration for us. As you see, there are a couple things we need to set up. We need to add a JDK, a Git, and Maven installation so that Jenkins knows where to locate those tools during the build process. Let's start with the Java JDK. So under JDK, JDK installations, click Add JDK. We need to fill in the name, which can be anything we want, to name this installation of JDK. Here I just put local JDK. By default, Jenkins will have install automatically checked. But since we've already installed the JDK on our local box, so let's uncheck install automatically. And fill in the Java home field with a path where Java is installed on our local box. If you don't remember the path, go back to the Java installation lecture to find it out. Next, let's configure our Git installation. We just follow the same process. Click on Add Git, then Git. Let's give this Git installation a name. I'm going to call it local Git. Since we're able to just type Git in the command to invoke Git executable, here we don't need to add the full path to Git. Just type in Git. Lastly, let's move on to configure our Maven installation. Click on Add Maven. Then name the Maven installation Local Maven. As what we did for JDK, just uncheck Install automatically. And like Java Home, Maven Home is the full path to where we have Maven installed. If you don't remember the full path, just go check the previous Maven installation lecture. It's noted, this Maven Home path doesn't include the bin directory in the end. Now that we've updated our Jenkins configuration, let's click on Save. You might have noticed that we have two buttons here, Save and Apply. What is the difference? The Apply button will save the changes we have made so far, but then remain on the current configuration page, so that we can continue making changes. The Save button will save our changes, but then take us to the previous page. Since I don't have any further changes to make, Save is the right choice for us. That's it for this lecture. I hope you've enjoyed it. Hello and welcome back. Finally, we've got all our preparation work ready. It's time to create our first Maven-based job. Let's take a look at the project we're building. The project we're going to build is hosted on GitHub. This is a fairly simple project which I have adopted from another project for the purpose of this course. This project is basically a web application which displays Hello World on the browser like this. Let's quickly go through the structure of this Maven project. I have a copy of this project on my local box. This project has two modules, Web App Module and the Server Module. The Web App Module has a web.xml deployment descriptor file which contains the minimum information about how to deploy this web application. The index.jsp file basically describes the HTML page we have seen in the browser, which is Hello World. The Server Module contains a very simple Java class and a corresponding test class which are not even related to the business logic of this web app. We'll take a closer look at them later in this course when we demonstrate the usage of some static analysis tools in Maven. You probably have already noticed that we have three pom.xml files in our project. Maven uses pod.xml files to describe the software project being built, including the dependencies on other external modules, the directory structures, and the required plugins, etc. In the pom.xml file, it also specifies predefined targets for performing certain tasks such as compilation and packaging. Now, let's start creating the Jenkins job. Here I am at Jenkins landing page. Click on New Item. Just type in a name. Let's call it Maven Project. Here we just go with a freestyle project. Once you've selected that, click on OK. Great! Let's move on to configure our Jenkins project. In the description field, Let's put this is our first Maven project. Next, let's move on to the source code management section. We'll check out the source code from GitHub. So here we check Git. Then we'll need to supply the repository URL. I have the Maven project open on another tab. Let's click the green Clone or Download button. Then click the small copy icon to copy the repository URL to clipboard. Then go back to Jenkins. Just paste in that value to the repository URL input box. Since this is a public repository, we don't need to provide any credentials to check out the source code. For the branch specifier, since this project only has a master branch, just leave it as master. We'll trigger this job manually in this lecture, so we won't check any of the options in the Build Triggers tab. The next thing we need to tell Jenkins is what to do with the source code. This is done by defining build steps. For this step, we'll create a Maven target and use our configured instance of Maven, which is called local Maven. Then Maven goals. Goals are basically the phases of Maven build. In case you don't know what is Maven build lifecycle, let's take a quick look at different phases in Maven build lifecycle. The default lifecycle comprises of the following phases. Validate. Validate the project is correct and all necessary information is available. Compile. Compile the source code of the project. Test. Test the compiled source code using a suitable unit testing framework. Package. Take the compiled code and package it in its distributable format, such as a jar. Verify. Run any checks on results of integration tests to ensure quality criteria are met. Install. Install the package into the local repository for use as a dependency in other projects locally. Deploy. Copy the final package to the remote repository for sharing with other developers and projects. These lifecycle phases are executed sequentially to complete the default lifecycle. In our case, we want to specify the Maven package command. This command would execute each default lifecycle phase in order, including validate, compile, test before executing package. We only need to call the last build phase to be executed. Let's go back to the Jenkins configuration page. In the Maven goals section, we put clean in package. The clean command will ensure we have a clean environment before executing any further Maven build steps. At this point, we're done with configuring this Maven job. Just click on Save. In the next lecture, we'll trigger this job and check the outputs. That's it for this lecture. I hope you've enjoyed it. In this lecture, we're going to actually trigger the Maven job we created in the last lecture and take a close look at the build process. Now we have opened the Maven job on Jenkins. Let's click Build Now to trigger the build. See, the build is scheduled. There is a blinking gray ball and a progress bar displayed under the build history section, which indicates the build is in progress. Now the gray ball turns blue and stops blinking, which means the build has completed successfully. We click the number 1 besides the blue bar. It takes us to the main page of this build. Then click Console Output to see the console output of this job. Let me walk you through the logs printed on the console to understand what happens during a build. As you see, Jenkins builds the project in a workspace under a shared directory on this logo box. First, it checks out the source code from GitHub. Then it's going to execute the Maven clean and package commands. Maven figures out the right order of building all the modules of the Maven project. The first one is the root directory, then the server module, and the web app module. For the root directory, it only does the clean command to remove any previous artifacts generated in the target directory. Then it moves to the server module. Jenkins is executing the sequential Maven build commands such as compile and test before packaging. After executing all the unit tests, it prints out unit test reports. Lastly, it packages the server module and produces the server.jar file under the target directory in the server module. After it's done with the server module, Jenkins moves to build the web app module. The build steps for the web app module are pretty similar to the server module. Clean, compile, then test. In the end, it packages the web app module and produces the web app.war file, which can be further deployed to a servlet container like Tomcat. Before we finish this lecture, let me show you how we can navigate through the workspace on Jenkins web portal. Here, we click the Maven project on the navigation bar to go back to the main page of this job. Then click Workspace. Now, it displays the directory structure of this workspace, which Jenkins uses to build the project. You can just click any directories to explore the workspace. That's it for this lecture. I hope you enjoyed it. In the previous lecture, we have seen how to trigger our build job manually. But the whole point of continuous integration is that whenever a commit is pushed to the central repository, the system would automatically build and test your application. The easiest way to achieve this is to let Jenkins pull the source code on GitHub periodically. If Jenkins detects a change in the source code based on the polling, it would then trigger a build. Let's see this in action. Here I am at the Jenkins landing page. Just click the Maven project we just created. Then click Configure. Scroll down to the Build Trigger section and check Poll SCM option. Then in the Schedule field, we'll need to fill in how often we want Jenkins to pull our source code. This field follows the syntax of cron. Cron is a very important concept working with job scheduling services such as Jenkins. Let me quickly walk you through some of the basic syntax of cron. In cron, each line consists of 5 fields separated by tab or white space. Starting from left to right, those fields are minute, hour, day of month, month, and day of week. To specify multiple values for one field, we have the following options. The star sign specifies all valid values. M-N specifies a range of values. A, B, Z enumerates multiple values. For example, 00*** means every day at midnight. 02-4** means 2 a.m., 3 a.m., and 4 a.m. every day. In order to detect changes immediately, we would like to pull the source code as frequently as possible. So here we just put 5* here, which tells Jenkins to pull SCM every minute. Then click Save to save the configurations. We end up with an extra item in our menu section, Git polling log. Let's check it out. It says polling has not started yet. Let's wait for about a minute and click Git polling log again. See, it shows us that Jenkins just checked out for changes, and in the end, no changes were found. Jenkins is doing this check every minute. Now, in order to trigger a build on Jenkins, we need to make some changes to the repo on GitHub, which then could be detected by Jenkins. Unfortunately, you won't have permissions to make changes to my GitHub repo directly. In order for you to follow along this course, you will need to fork my repo on GitHub, which will create a copy of the repository under your user ID and allow you to freely make changes without affecting the original repository. Let me show you how to fork the repository. Just go to my GitHub repository, https://github.com/jlee-tutorial-maven-project. Now we have opened the Maven project repository. Let's click the Fork button to fork the repository. See, we have got our own version of Maven project repository. Now we can tell Jenkins to check out source code from the forked repo instead of the original one. And click the Clone or Download button, which displays the Git clone URL for you to download the repo. Here, you need to select using HTTPS instead of using SSH, so that Jenkins won't need SSH credentials to check out the repo. Next, click the clipboard icon to copy the URL to your clipboard. Go back to Jenkins and click the Maven project we just created. Then click Configure. Move to the Source Code Management section and replace the original Git URL with a new one. Then click Save to save the configuration. Before we push changes to the GitHub repo, one last thing you need to do is to set up the SSH key for your GitHub account so that we can push changes from your local box to the central GitHub repository more easily. SSH keys are a way to identify trusted computers without involving passwords. You can generate a SSH key pair and save the private SSH key in your local box and add the public key to your GitHub account. Then you can directly push your changes to GitHub repository without typing password. First, you should check if you already have the SSH key available in your local box. The public key file usually sits under the hidden SSH directory in your home directory, and it usually ends up with .pub extension. I don't have an SSH key pair in this computer, so I will go ahead and create one. If you already have one, feel free to skip this step. Now, let's follow the instruction on the GitHub website to create a SSH key pair. Just copy the SSH keygen command to your terminal to create a SSH key. Here, we stick with the example email address. Just keep hitting enter to go with the default options. The private key and public key have been generated. What we'll do next is to start SSH agent in the background and add the SSH key to the agent. Now, let's copy our SSH public key to the clipboard so that we can add it to the GitHub. Finally, we go back to the GitHub profile and click Settings, SSH key and CPG keys. Click New SSH key and give the public key a title. And paste the public key here and click Add. There you go. The public key has been added to the GitHub. Finally, let's check out the repo and make some changes. Go to the forked Maven project repository under your GitHub account. Make sure you go to the forked repository under your GitHub ID, not the original one. Otherwise, you won't have permissions to push changes to the repository. And click Clone or Download button. Here, you need to select using SSH instead of using HTTPS. Next, just click the clipboard icon to copy the URL to your clipboard. Then we go back to the terminal, issue git clone command, and paste the URL and hit enter. Now, Git is downloading the repository to your local box. The repository has been downloaded. Let's enter the repo and do an empty commit. Just put something as the commit message, then exit. Now, we can do git push to push the latest commit to the remote repo. This should trigger a build on Jenkins. Let's head back over to Jenkins. Refresh the git polling log. See, it says Jenkins has detected the changes, and we can see a build has been scheduled. After the build is complete, click this build. As you see, this build is successful, and it says the build is started by a SCM change. In this lecture, we have demoed how to configure Jenkins to pull our GitHub repo periodically so that a build will be triggered